Okay, so in this example we've got a product, so we're going to use the product rule, and we're also going to use the chain rule. So if we start off with the question, y equals x squared e to the inverse tan of 3x. Let's say we let u be equal to x squared and v be equal to the inverse tan, sorry, that's not quite right, e to the inverse tan of 3x. Okay, so we're going to differentiate both of those and then use the product rule. So u prime is easy. The derivative of x squared is 2x. Now, the derivative of v is a little bit trickier here. So when we look at v, let's do it down here. V prime, the first thing you see is an e, so whenever you differentiate an exponential term, an e term, you keep exactly what you start with. So it'll be e to the inverse tan of 3x. Now you've got to then multiply by the derivative of the power. And the power in this case is inverse tan of 3x. So the derivative of that is going to be 1 over 1 plus 3x squared. So that's what you get when you differentiate the inverse tan, and then you have to differentiate the 3x. So differentiate the 3x, you're just going to get 3. Okay, so it's a little bit messy. That's 3e to the inverse tan of 3x over 1 plus, and if we want to square it out, we can, 9x squared. Okay, so let's put it back together then as a product rule problem. To finish off, we're going to get dy dx is equal to u, which is x squared, by dv dx, or v prime, which is 3e to the inverse tan of 3x all over 1 plus 9x squared, plus v, which is e to the inverse tan of 3x by u prime, which is 2x. Okay, now if we want to, we can begin to factor something out of that. There's an e to the inverse tan of 3x in both cases, and there's also an x in both cases. So we can make this if we want to, and it's useful for multiple choice questions. Let's take out an x, and let's take out e to the power of inverse tan of 3x. And if we take that out of the first term here, we're going to be left with a 3x over 1 plus 9x squared. And out of the second term, we've got the x and the inverse, the e to the inverse tan, so we just have 2. Okay. So it's not a very nice problem, nothing very delicate about it, but that's the way it works out. Okay, thank you.